Okay, so we will continue with the reaction, the balancing of reaction as that of chemical equation. Now the example which I am going to take is of sodium reacting, okay, sodium reacting with water, giving you sodium hydroxide plus hydrogen. Now the very first thing what you all have to do is box this reactants. After boxing this reactants, what you all can do is make a table of LHS versus RHS, okay, sodium, then hydrogen and oxygen. If you can see, there is one sodium on both the sides, one molecule of oxygen on both the sides. But hydrogen, there are two molecules of hydrogen along with two molecules or three molecules of hydrogen over here. So if I talk about balancing hydrogen, what we are having here is 3 hydrogen on this side while 2 hydrogen on this side. So basically what you might do is, doing just multiplying 2 and 3 on the either side, which according to the steps which I have taught you. But here this equation is kind of a tricky equation, wherein if you multiply this by 3, this becomes 3 oxygen, okay, this becomes 3 oxygen. For this to become 3 oxygen, what you have to do is, you have to multiply by this 3, and again the hydrogen over here will become 5. So what I'll do is a simple trick. Okay, first we will try to multiply Na with 2 on both the side. Why I am doing this, you will get the answer. Because according to those steps, if you try to solve, it's quite complicated. So 2Na plus H2O gives 2NaOH plus H2. Now here what happens is, since Na has become 2, O also has become 2. Here LHS on LHS, O is 1, RHS O is 2, LHS Na is 2, RHS Na is 2, so Na is balanced. If I talk about hydrogen, there are 2 hydrogen and 4 hydrogen, okay. So if you notice that this is exact half of this, while this is exact half of this. So in such conditions, what you do is, you multiply this side O and H, not Na, by 2. So if I talk about 2Na plus 2H2O gives you 2NaOH plus H2. And if you check on LHS as well as on RHS, there are 2Na, 4 hydrogen atom, 2 plus 2, 2 into 2. Here 2 hydrogen plus 3 is 2, that also equals to 4. And oxygen atom, 2 on each side. So this balances your chemical equation. Okay, now what you're going to do is solid, gas, or maybe liquid, gas. since this both are solid and liquid, we will assume this is liquid. So this is how you balances the chemical equation. Now that we have learned upon how to balance the chemical equation, we will move on to chemical reactions. Okay, the first part of the chemical reaction So the first part of the chemical reaction which you all have in your books is the combination reaction. Okay, as the name suggests, what does this do? Combination reaction means to combine. Okay, combination, what is combination made up of? Combining different things. So combination reaction here also means combining things. Okay, supposedly there are these two different separate things, I combine them together. Combination reaction. Let us take an example. There is a carbon atom, there is oxygen. On combining, it will give carbon dioxide. So this reaction is known as the combination reaction. Okay, so there are various examples in which there are two separate reactants which react together to form a single product. Another example would be your formation of water. H2 plus O2 gives you H2O. Again, I'm not balancing this, but then if you balance this reaction, it will give fine. So hydrogen and oxygen, those are two reactants, they combine together to form water. Okay, so this is the combination reaction. And the third example which I would like to give you all is, maybe calcium plus oxide, Ca plus O2 gives you CaO, calcium oxide. Fine. So this is combination reaction, wherein two single substances combine together and react together to form a combined product. After combination reaction, this is like joining in. Now let us understand something of breaking up, like what we learn in nutrition. What is respiration? It is breakdown of glucose into simpler substances. So if I take that simple example of glucose, wherein glucose C6H12O6 is broken down with the help of water to give carbon dioxide plus water plus energy. So this is, I've not balanced it. If I balance this reaction, it will be 6O2 gives you 6 of each. Fine. So this is the simple reaction of glucose getting broken down into carbon dioxide and water. So this kind of reaction is known as decomposition reaction. In combination, what happens? Two substances combine to form a single product. In decomposition, what happens? Opposite of combination, one substance break down to give two products, or maybe more than that. So if I give you all more examples of decomposition reaction, a classic example of ferrous sulfate ferrous sulfate with the presence of heat, you draw a triangle, you spell it, it's one and the same, gives you ferric oxide plus sulfur dioxide plus sulfur trioxide. Now again, if I balance this reaction, just take it 2, so I guess it balances, the whole reaction is balanced. So this ferrous sulfate in the presence of heat divides into 3 forms. So this is a kind of decomposition reaction. Okay, so now up till now what you have learned is the composition reaction, that is the combination reaction, decomposition reaction. Now what you are going to learn is displacement reaction. Okay, so if I talk about displacement reaction, here what happens is a substance is being displaced. Supposingly, if I have this whole substance along with the pen as well as the cap, and if I don't have the cap of this, so what might happen is this cap might fit on this pen. So instead of the cap being here, the cap has went there. So such kind of reaction is known as the displacement reaction. Classic example is when there is a experiment to you all, of course. Iron nail is being immersed into a solution of copper sulfate. Now what happens is copper sulfate, what it will do is it will do the process of displacement, and suppose I write the reaction iron nail Fe plus copper sulfate CuSO4 liquid, of course. Now what happens is gets formed or gets displaced into FeSO4 plus Cu. So exactly as this, the cap of the pen is being interchanged. Similarly, your iron is separate. There is a solution of copper sulfate. After the displacement reaction, what happens is the solution becomes iron sulfate and copper is free. So that is what iron is the nail. When it is immersed in the solution of copper sulfate, the nail or the iron on the nail gets reacted with the copper sulfate and iron sulfate is formed. Therefore the dark blue solution turns out to be faded. Fine. So this is displacement reaction, wherein one substance is displayed into another substance. So there is one more thing similar to this. You can have zinc, you can have lead, Pb. Okay, so if this reacts with respective copper sulfate, you will have ZnSO4, you will have Pb twice, I guess, SO4. Fine. So this is all, that is displacement reaction. So after you know what is displacement reaction, I'll tell you what is double displacement reaction. In the previous thing, when I showed you all this example, there was just one cap and two pen. Now here, there are two caps and two pens, okay? Each cap has been inserted on the pen. Now, the cap from this pen goes over here and the cap from that pen comes over here. So, this is known as double displacement reaction. How? We will see. Okay, so there is NaSO4 along with barium chloride which gives you barium sulfate plus sodium chloride. Now here what happens is this Na moves to this chloride, this chlorine, and this barium moves to this SO4. So there is not just one displacement, the reaction occurs in the form of double displacement reaction. So today I end up with this topic. There are few topics which are left, which I'll cover in detail probably in the next class. Thank you.